Okay, girls, this is just a video going through the prep test for geometry, properties of geometrical figures, triangles and quadrilaterals. Name these quadrilaterals and you can choose from the following: kite, rhombus, parallelogram, trapezium, rectangle or square. The first one, anyone? Just tell me what you notice about that shape. It is a trapezium. Can you tell me what's being shown in that figure? Yeah, we've got one pair of opposite sides parallel. What about this shape here? Yeah, because you've got two pairs of opposite sides parallel, so it's a parallelogram. The reason it's a parallelogram is that two pairs of opposite sides are parallel. While we're here talking about parallelograms, can you tell me what you know about anything about it? Tell me something about the parallelogram. Two pairs of opposite sides parallel. What else? Give me some features. What about the opposite sides? Are they the same length? Yeah. What about this angle down here? Does it equal any other angle? Yeah. So those two angles are equal. See this angle here? Which one does that one equal? Yeah. They're just opposite angles in a parallelogram are equal as well. So just a few things there. Do you know what this shape is? Yeah, it's like a parallelogram, but all four sides are the same. The opposite sides are parallel, but they don't have to put that there for us to know that it's a rhombus. Okay, the next one is, yeah, that one's easy. What size are the angles? Tell me about the opposite sides there. Yeah, parallel and equal in length. All right, good. What's this one? Okay, and that's showing me all 90 degrees, all four sides are equal. And the last one is a kite. See this angle here? Tell me which one, other angle. Yeah, girls, this has a line of symmetry down the middle. So if you fold it, one half of the kite is identical to the other half. So these opposite angles are equal. So next question, 2. What types of triangles are these?
The middle one's an equilateral.
Yeah, the middle one is equilateral. No. Isosceles. Now, yeah, isosceles, two sides the same. Now, tell me, we're going to do a little bit more than what's here. And the last one, 3 different side lengths, is scalene. Now, girls, tell me which one. Let's look at this scalene triangle here. Oh, actually, the isosceles. Do you know which angles are the same? If it's got two sides the same, 2 of the angles will be the same as well. Do you know which ones are the same? I'm going to turn. No. I'm going to turn. Girls, see. Those, see, look what I'm doing with the isosceles. I've turned it so that the 2 equal sides, I'm putting my hands down like that, my fingers. If those 2 sides are the same, the 2 angles in the corner are the same with isosceles. So remember, an isosceles triangle has 2 sides the same, but those 2 angles that I've marked out, they're the same as well. Do you know the angle size in an equilateral triangle while we're here? How big is, do you think all the angles are the same?
Yeah.
All right, do you know how big they are? Yeah. All the angles are the same and they're all 60 because 60 plus 60 plus 60 is 180 because all the angles add up to 180. All right, we know that's scalene. Okay, girls, what types of triangles? We've got acute angled, right angled or obtuse angled. Yeah, they've put them in the right order. Acute angled, right angled, obtuse. You only need to have one obtuse angle for it to be obtuse angled. Okay, we'll go to the second page. Okay, yep. Okay, question 4. Refer to this diagram below. Name one of the intervals at right angles to the interval QT. QT is this in red. Actually, can you tell me a line, that's QT, the interval QT. Can you tell me a line or an interval? An interval is a line with fixed length. See, in geometry, when you do lines, you're supposed to put arrows on the end. This is an interval. It's like a line for you. All right, tell me what's at right angles to this interval.
That P and Q
PQ.
equal the same and S and T equal the same.
Yeah, they're at right angles, that's right. So, girls, this is a right angle like that. or that's a right angle.
I get it.
So if QT, tell me what's at a right angle to QT. PQ. So you could have put PQ, or what other answer could you have put? Or ST. Or ST. Do you get that? So girls, name one of the intervals at right angles. So your answer could have been PQ or ST. You didn't have to put both of them. You just need to put one of them. Good. Next question. Name an interval parallel to ST. So I want something parallel to ST. What's parallel to ST? Guys, which line is parallel to
PQ.
Yeah, PQ is parallel to ST. Does that make sense? Girls, there's ST. What's parallel to ST? It's PQ. The following figure is a kite. You know what I like to do with a kite? I like to turn it the way that you'd look at it. Use small lines and arcs to show all equal sides and angles. I'm going to turn it. All right, what equals what? This side equals this one. So you must put single dashes, or you could put doubles as long as they're the same. What else is equal?
The opposite sides.
These. So single dashes means those two are the same. Double dashes mean those two are the same. If you think how you can fold a kite in the middle,
it will equal the same.
well, what about this angle? Is that equal to anything?
Yeah, it's opposite side.
Opposite angle. So they're the same. Now, girls, do you think up there equals down there?
No.
It doesn't. That one's often bigger than this one.
The bigger part will fold over.
Yeah, if you fold this there, that ends up way up there. If you folded it here, that would end up over there and it would be smaller. That angle's smaller than that one. So just with a kite, if you put a line down the middle, everything on the left is the same as everything on the right. That's the best way to think of a kite, okay? We got it? So I'll turn it back this way. It should look like that. So you have to use the small lines to show equal sides, and you can't put 1, 1, 1, 1. These need to be 2 dashes to show that they're different to that. All right? Now, it says a rhombus is a quadrilateral. What's a quadrilateral? Quad.
Or equal sides.
How many sides does... A quadrilateral just means that it's a 4-sided shape. It says write down 4 other things that you know about the properties of a rhombus. So this is a rhombus. Tell me what you think you know about a rhombus. What's equal? All?
Doesn't it have, like, isn't a quadrilateral equal sides?
No, we're talking about a rhombus. Tell me what you know about a rhombus.
Equal sides.
All of them?
Yeah.
So we go 1, 2, 3, 4. All sides are equal. Good.
The angles aren't equal, though.
Some of them are.
The 2 going that way is equal.
So this
How do
one,
you know if it's equal? If you fold the square in half and then both all the corners,
Yeah,
all the corners
sit on top of
same,
each other.
they're all
So
equal.
girls, do you think, what else? What about something else about the opposite sides? They're what? All the 4 sides are equal, but there's something special about the opposite sides. I haven't drawn it on. Do you know? They're what? Girls, with a lot of the shapes, you've either seen equal markings or parallels. Tell me what you know about the opposite sides. There? Do you think that's parallel to anything?
They're parallel to each other.
Yeah. Opposite sides, but how many pairs of opposite sides? That's 1 pair. So, yeah, we can just say the opposite sides are parallel. Opposite sides are parallel. So that's 2 things we know. So, all 4 sides are equal. Opposite sides are parallel. Do you know why I put 1 arrow, 1 arrow, 2 arrows, 2 arrows? Do you know why?
Because so it informs us that there's actual parallels.
Yeah, and that these parallels are different to those ones. All right, good. Now, what about something else? Now, we've done the sides. Let's try some angles. That one?
Angle is equal to the opposite angle.
Yep.
And the other angle is equal to the opposite.
So I'll
Okay,
put...
now I can just smell my fingers.
All right, girls. So, see how I've got... I might do these ones solid. See that? So those shaded ones are equal and those other 2 are equal. We say opposite angles,
Are equal
not...
to each other. Like,
Yeah, opposite angles are equal. The opposite angles are equal, but not all 4 of them, okay? Now, girls, there's something else we can do. And I'm going to have to draw some lines in. What are those lines called?
Line of symmetry.
No. Nearly.
Line of, what's the corresponding angle you
Yeah, wait, no. Let's do something about the diagonals.
Diagonal lines.
All right, I need a ruler, girls. I'll just pause. Divided shapes. We need to draw in the diagonals. Now, I've done them in a different color. They're in pink. Tell me, so the diagonals, girls, they're not equal in length. Whenever a shape is tilted to the side, one diagonal is longer than the other, but don't write that. Tell me about the diagonals. What angle do you think they cut at?
90.
Yeah. So the other rule is that the diagonals, and I'm writing this one in pink, bisect. Do you know what bisect means?
To cut in half.
Yes, bisect each other at right angles. Shh. The diagonals bisect each other at right angles. That means cut in half. That's what bisect means, to cut in half. Lines of symmetry and order of rotational symmetry for the following shapes. Now girls, when a shape has equal sides, when you fold it, the diagonals, when you fold it crossways, the corners do sit on top of each other. So girls, how many lines of symmetry for a square?
4.
Because you can go 1, 2, 3, 4. So 4 lines of symmetry. Line symmetry is 4. I mean, I can draw it just here. So we've got 1,
And the
2.
rotational symmetry is 4 as well.
Yeah, 4. Now, rotational is when you put a, girls, rotational is when you put a dot in the middle and you start turning the shape around. Now, if I do that, if I turn, that side ends up there, then it ends up there, then it ends up there and back there. If it's a regular shape with 4 sides, it'll have rotational symmetry order 4. Now, girls, in the test, you may not get a square. We might give you another shape, all right? Now,
Is that whole section worth 6 marks?
yes.
Just for that.
Yeah. Now, girls,
Better get it right.
what about a parallelogram? We did this yesterday. If I go down here or across there,
It's only got 1, right?
well, I don't think, no. I don't know. And if I go there, that ends up there. It's got none. Line symmetry is none. Line. If you fold it, girls, if I fold it there, watch. That corner sticks out here. This corner sticks out. So it's got 0 lines of symmetry. It doesn't have any. And if I go like this, that ends up down there. Girls, we did this. So this has no lines of symmetry. If I fold it there, that would end up over here. What you might want to do in the exam, girls, there's no reason why you can't have a bit of paper, cut the shape out and try it yourself. You can if you want.
Wait, can we bring notes in the exam?
Yes. Oh, no. No, no notes. No notes.
Like just
You could bring some paper, cut the shape out, or you can even fold your exam paper if you want.
I'll tell you something.
You know what you would
Last
do?
exam, I saw Grace.
Rotational symmetry for this. So if I put a dot in the middle, how many times would it sit back on top of itself in one full spin? I'm going to spin this around. Notice this bottom corner is sitting down there. Does that look the same as what it did? 1, it does.
Well, like because of the angle, it's not at the right length.
Girls, does this have rotational symmetry? Yes or no? The parallelogram, if you spin it once, halfway round, then that will end up here halfway round, and then when you keep spinning, that will end up back there. So it's got rotational symmetry too. In other words, when you do a full turn, it will sit on top of itself twice. Halfway and then at full way.
Right, if you're paying attention. you would-
Line symmetry, girls, it's not just 4. Girls, I could do 1,000,000 different lines, and this would keep, it doesn't have to be,
Keep adding up.
So it's an infinity. Do you know what?
It's an
Infinite or infinity. That means the number is very, very large and it actually goes on forever and ever. So girls, every single line I do on a circle is a line of symmetry. There's lots of them. I could draw 1,000,000 lines of symmetry or more. So it's called an infinite number or infinity. That's the symbol for it, a sideways 8. Rotational, girls, if I just keep moving it a little bit, it's infinity as well. So infinity, you put infinity if you want, or infinite, infinity. Okay, we'll continue the rest tomorrow.